we will discuss some numericals from ray optics in this video lesson. Question number 9.3 from exercise of NCRT. A tank is filled with water to a height 12.5 centimeter. The apparent depth of a needle lying at the bottom of the tank is measured by a microscope to be 9.4 centimeter. What is the refractive index of water? If water is replaced by a liquid of refractive index 1.63 up to the same height, by what distance would the microscope have to be moved to focus the needle again? Now here the real depth in case of water is given 12.5 centimeter and its apparent depth is 9.4 centimeter. So refractive index of water is real depth by apparent depth. So 12.5 divided by 9.4, that will give you the refractive index of water. Now when water is replaced by some other liquid whose refractive index is given 1.63 and real depth is same 12.5 centimeter, then find out its apparent depth. So mu is equal to HR by HA, real depth by apparent depth. Substitute and we get the apparent depth as 7.67 centimeter. So earlier the apparent depth is 9.4 centimeter. Microscope is focused at 9.49 centimeter. Now we have to focus it at 7.67 centimeter. So it is to be moved up through a distance 9.4 minus 7.67 equal to 1.73 centimeter. Now question number 9.4. In figure A and B, show refraction of a ray in air incident at 60 degree with normal to a glass air and water air interface. Respectively, predict the angle of refraction in glass when angle of incidence in water is 45 degree with the normal to a water glass interface. So from figure that is given in the question, we can write refractive index of glass is equal to sin 60 by sin 35, angle of incidence and angle of refraction is 60 degree and 35 degree. Similarly, in case of water, refractive index of water is sin I by sin r, so sin 60 by sin 41. Here I is angle of incidence is 60 degree, angle of refraction is 41 degree. Now refractive index of glass with respect to water is equal to sin I by sin r. Here angle of incidence is given 45 degree and r is not given, so we have written here sin r. Now we know that relative refractive index, that refractive index of glass with respect to water is equal to ratio of refractive index of glass to that of refractive index of water. Now substitute the values. After substituting values and rearranging, we get sin r is equal to 0.6181, which is nearly 38.2 degree. So in this way we can solve question number 9.4. Question number 9.5. A small bulb is placed at the bottom of a tank containing water to a depth of 80 centimeter. What is the area of the surface of water through which light from the bulb can emerge out? Refractive index of water is given 1.33. Now see, here in the diagram, this is container and this is the bottom where bulb is fixed. Now rays of light are coming out from here. Now these rays of light will get refracted and come out in the air till the angle of incidence is less than critical angle. As soon as it is equal to critical angle, the refracted ray just grazes along the surface of water. That is, light will not go out. So this is your angle of critical angle here. Again critical angle here. Now it is given refractive index of water is 1.33. We know the relation sine of critical angle is equal to 1 by refractive index. So substituting the value 1.33 is 4 by 3. So we get sine IC is equal to 3 by 4. And from figure you can see in this triangle tan IC is equal to R by H. So tan IC is equal to R by H. Now sine IC is 3 by 4, so tan IC is 3 by root 7. So put the value of tan IC. Then from here R is equal to 3 by root 7 H. Now area through which light will come out. So this R is the radius of the circular face through which light will come out. Light will come out from this area. R is the radius, so it will come out from pi r square area. So here area is pi r square, pi r is your 3 by 7 h square. H is given 80 centimeters, so put its value, you will get the value of area. So area is equal to 2.6 meters square. Question 9.7. Double convex lenses are to be manufactured from a glass of refractive index 1.55 with both faces of same radius of curvature. What is the radius of curvature required if the focal length of the lens is 20 centimeter? So focal length is 20 centimeter, given lens is convex, refractive index of the glass is 1.55, radius of curvature is same. Now here one thing you can see, this is first face and this will be your second face. So this is the center of curvature. So this is the radius of curvature R1, which is in the direction of incident ray, and for this face this is the center of curvature. This is radius of curvature R2, which is opposite to incident ray, hence it will be taken as negative. So substitute the values in the lens maker formula, you will get the result R is equal to 22 centimeter. Now question number 9.8. A beam of light converges at a point P. Now a lens is placed in the path of a convergent beam 12 cm from P. At what point does the beam converge if the lens is convex lens of focal length 20 cm and B a concave lens of focal length 16 cm? Now you can see in the diagram, if there would have been no lens in the path of the two rays, the two rays meet at point P. Now if we place a converging lens in its path, so because of the presence of this lens, the rays of light, instead of converging at point P, they will converge at point ahead of P. Let it be at I. So image will be formed at I. Now here point P acts as virtual object whose real image is formed at point I. So this 12 centimeter distance, lens is placed at a distance 12 centimeter from the lens. So this distance, this is your virtual object. Virtual object. So this distance is 12 centimeter distance is U, and this distance is V, and focal length is 20 centimeter. Now substituting the values, u 12 centimeter, focal length, convex lens positive, focal length 20 centimeter, we get the value of v as 7.5 centimeter. So this is the point where we get its image, that is they will converge at point 7.5 centimeter from the lens. Now in case the lens that is placed is concave, so it is a diverging lens. So earlier if there would have been no lens, the two rays would have converged at point P. But if we place a diverging lens in its path, so what will happen? Because of the presence of the lens, the rays will diverge after refraction, so they will meet at some other point behind after P. So let it be at I. So here P will act as a virtual object whose distance is 12 centimeter from the lens. And again here focal length is given 16 centimeter, since concave lens is concave, so focal length is negative, so f is minus 16 centimeter. Now put the value, you will get v is equal to 48 centimeter. Question number 9.9. An object of size 3 centimeter is placed 14 centimeter in front of a concave lens of focal length 21 centimeter. Describe the image produced by the lens. What happens if the object is moved farther away from the lens? So here you can write all the information that is given in the question at one point, like height of the object 3 centimeter, object distance minus 14 centimeter, focal length, as lens is concave so it will be negative, minus 21 centimeter. We have to find v and hi. Now using lens formula, you find the value of v and magnification, hi by ho is equal to v by u. So you will get height of the image 1.8 centimeter. As object is moved away from the lens, the virtual image moves towards the focus of the lens and progressively diminished in size. Now some questions on your lens maker formula. Question says find the radius of curvature of a convex surface of a plano-convex lens whose focal length is 0.3 meter and refractive index of the material of the lens is 1.5. Now here the lens is plano-convex, so one of its face is convex and other is plane. So if first is convex and second one is plane, then R1 is equal to R, it is positive, and R2 plane surface, so its focal length is negative. Again focal length is given 0.3 meter and refractive index 1.5. Substitute the values, you will get R is equal to 0.15 meter. Now second question, a double convex lens has a radii 20 centimeter. The refractive index of glass is 1.5. Compute focal length of the lens in air and when immersed in carbon disulfide. When the lens is placed in air, refractive index is given 1.5 glass and radius of curvature is 20 centimeter. So R1 is 20 and R2 is minus 20. Substituting the values, we get the focal length in air as 20 centimeter. Now when the lens is placed in carbon disulfide, so we have to substitute mu refractive index of glass with respect to carbon disulfide, which is equal to ratio of absolute refractive index of glass to that of refractive index of carbon disulfide. Now substitute the values, you will get a refractive index of focal length of convex lens in carbon disulfide as minus 125.4. Now focal length is negative. Negative focal length means the lens is diverging. The lens is behaving like a diverging lens. Now the lens is convex, but since it is placed in carbon disulfide whose refractive index is greater than the refractive index of the material of the lens, so nature of the lens gets reversed. Here it is behaving like a concave lens, diverging lens. So whenever a lens is placed in a medium whose refractive index is greater than the refractive index of the material of the lens, the nature of the lens gets reversed. Convex lens will behave like a concave lens, and concave lens will behave like a convex lens. And if it is placed in a medium whose refractive index is equal to that of material of the lens, in that case no refraction will take place. And if it is placed in a medium whose refractive index is lower than the refractive index of the material of the medium, in that case convex lens will behave like a convex lens and concave will behave like a concave lens. One more question is question 1.2, then question, this is also similar question. Now here you can see refractive index of the material of the lens is greater than the refractive index of the medium. Convex is behaving like a converging lens, but here the refractive index of material of the lens is equal to refractive index of the medium. No refraction is taking place, and here refractive index of material of the lens is less than the refractive index of the medium. The nature of the lens gets reversed. Convex is behaving like a concave diverging lens. Converging lens behaves like a diverging lens. Very important. One similar question is here. Now here are some questions based on lens maker formula for your practice. Just go through it. Thank you for watching.